Good afternoon, everyone. I welcome you all for our day four of the FDP. And in today's session, we need to complete our project on multiple disease detection. And then we'll be experimenting on latex also related to this project, and also one more project. I will be doing some editing over the overleaf. Okay, so that will help us in making the templates for our research paper. All right, so let's get started. I've already shared the code and the data set with you. Okay, so you can do a practice. Meanwhile, let's have a discussion first. So in the last class, I have been reached till data visualizations. Okay, data visualizations. I have reached till here, and next we need to do data modeling. That is what we need to perform. Okay, that means we need to apply model on the data set. Okay, and our data set is not it's in a CSV file format. That means we have already created data frame where features are present. Okay, so our data set is in this format, a tabular format, and we need to select the relevant features from the data set, and then we need to apply model on it. That is what our task. Then we will evaluate the model and see what scores or what results are coming. All right, fine. This is what we are going to do. Now, meanwhile, I want to add something for today's session. My experience I want to add. Well, when it comes to research, our expectation is to add novelty to our work. That is what we want to do. And in my last sessions, I told you that where is the scope? Where is the scope? In research, either you are going to set up an architecture, or either you are working on a neural network. Okay, this side or that side. Or either if you have made the entire change in the concept, then you can combine both in making a novel model. That is what you can do. However, making all these architectures, making all these models requires what kind of data set you have. Let me clear you this thing first. Let me clarify about data. Well, well, I think in the last lecture I told that we will only pick up a topic for our research subject to the availability of data. If your data is available open source, then it's a good idea. Other people have worked on this data set and got some results, like as we have done brain tumor detection, a paper which I have shared and done the entire code based on it. There, the authors have used DenseNet, and we have applied other models also, and saw what results are coming. So, data availability is important. Any research paper, good quality research paper published in some journal, have worked on this data set, results are available, then we can proceed to work on this data set. Okay. One more thing I want to add. If you want or the idea is to change the entire logic of a particular algorithm. or for a particular technique. This is what you want to do. In case if you want to change the entire logic, you needed to understand the maths properly, you need to understand the data properly. That's very much important here. Yesterday I had a session, and my session was based upon a research paper. A research paper, let me show you that research paper also, and we'll talk for some time based on this research paper. Okay, to give you an idea what happened, let me share my entire screen, and here is my entire screen. Okay, and the research paper which I have discussed yesterday. Here is a research paper. Hex former, hyperbolic vision transformer with exponential map aggregation. This is the research paper which I discussed yesterday. So, what is in this research paper? Like, what's matter of publication and why I am highlighting it? They told the title is Hex Former. I think the project which we have done previously related to the brain tumor, we applied all pre-trained models, VGG16, 19, ResNet, EfficientNet, all pre-trained models. Vision Transformer also we applied, VIT, Vision Transformer also we applied. And we had a discussion, sir, this much accuracy we are coming 98, 99, and whether this accuracy is good or not. We got some review questions, and a lot of things were happening, and the problems are overfitting in the model. Okay, uh, these are the issues with the machine learning. Such kind of issues, such kind of reviews, such kind of questions will always come, and we need to reply. We need to reply. And then suggestion came that you need to do more augmentation in the data, make it more diverse, make it more challenging for the model to understand. So now next time model will not bring that much accuracy. Model will be a bit like, if it is 99, then we want to put it like 98 something, that will be okay. Authors in this paper, Hex Former, they told data images so far you are considering as flat in nature. Flat in nature. Okay, for example, if we make a map, or let's say globe of the world on a 2D image, it will be look like this something, and the country or the island which is being present here, it will look in this way, distorted, a bit distorted. They are not of that particular shape or a size, but they look distorted because your way to represent the data is in a flat surface. That's what the problem picked by the authors in the research paper. They told, no, we are not interested. You are showing the image in a flat mode, and you are applying all these techniques over the flat image data, and you are performing the feature extraction, and then you are training your neural network and publishing the results, but we are not interested. This may result into overfitting in the model, this may result into unstable gradients, and that is why the reviewers ask the question that what happened, how you got this much score, how. So the problems are in front of us. The problems while doing any research is in front of us. What data to select, what model to select, how to take this challenge of overfitting. It's not like reviewer will ask you a question. You yourself ask a question. that how to solve such kind of problem, because this will come, this will obviously come. Okay, you need to justify your result that we have achieved. How to justify your result? If you have answers prior to these questions, then doesn't matter what the reviewer will ask next. You are ready with your answers. Okay, why selected? What happened? You have already published in the results. So, with the idea, the authors came in this research paper. They told that images which you are considering as flat, in reality, there is a hierarchical relationship, or they can be represented in a form of hierarchy or tree like structure. How? What do you mean by this? Vehicle is related to car. Car is related to car is related to transportation. Transportation is related to convenience. So, there is a layered or levels of understanding. Okay. For example, if you consider any of the image, if you do have the features, these features exhibit hierarchical relationship. Like, that's what we study in our computer science, in object oriented programming subject. Okay, tree. This is the root node. Then we do have the child nodes, and then we are having the grandchilds. This is what we do have, a hierarchical relationship. Okay, therefore, authors told that you have to consider your data in a hierarchical way, tree like structure, and it should be represented on hyperbola, that is curve, not on a flat surface. No, no, not at all, not on a flat surface. Your data should be represented according to the hyperbola. That's what they told. And they came up with a maths that is called as Lorentz equation. That's why madam told me, sir, this workshop should be like related to mathematical concept, mathematical perspective. We want this workshop to be done in that way. So I told madam, yes, fine. So, like, if you want to add a novelty in your work, you should be knowing how this data can be represented. Is there any way to represent the data? Because such challenges are coming. Model is not stable. Model accuracy results are not stable. They are changing. Model can collapse. If we give new data to the model can collapse. There is an overfitting shown in the model. What can be done? Okay, how to understand or represent our data. There are certain challenges. You need to think first. These are the steps for doing a research. Title, topic identified, data identified, then what you can do with this particular data, what sort of model you can do with this particular data. You are reading research papers also, you are reading other references, literatures also. They have done some work, you have identified the problem, but what's the, you are like interested to make the objectives. My aim is to perform the classification, my aim is to perform segmentation, my aim is to perform this, the aim of this project, aim of this research to build this, and here are the objectives. Objective number one, to do the literature. Second, to identify the problem statement. Okay, third, to design and develop the novel algorithms, and four, to evaluate the results. Here I made the four objective. My aim is clear, but how to achieve it? Novelty, that's a question. How to, so these guys told that because of such and such problems, represent data according to the Lorentz equation, and that should be a hyperbolic or curve. So all the points should be present on the curve, not in the straight line. That's what they told. And based upon this phenomena, the authors have changed the entire entire structure of vision transformer. Vision transformer was having, what we do, image, we divide it into patches. That is what we do in the image vision transformer, and after patches we convert them into embeddings. This is what we do, or the vector representation. The authors told that embeddings should also be hyperbolic in nature. Okay, then we apply attention mechanism. Authors told that attention mechanism should also be hyperbolic in nature. Then we apply multi-layer perceptron or neural network. Authors told that neural network should also be hyperbolic in nature. So they added novelty here. Three serious set of novelty they have already mentioned. And all the equations are according to this hyperbola. Equation of hyperbola is x square upon a square minus y square by b square equal to 1. This is hyperbolic equation, and hyperbola looks like this. This is hyperbola. Okay, we do have the foci. Okay, and we are having the tangents. This is hyperbola. So the authors are saying that at the center, at the core, general details of the data is present. Then as we move away from the center, other important details of the data is present. For example, if this is animal, this is a dog, this is how the eyes of the dog looks, this is how the legs of the dog looks, this is how ears or other features of the dog looks. So center, it's a general animal. Then we are moving towards more depth, then other features are going to be incorporated. That's what proposed in the research paper. All right, fine. This is the concept which is given in the research paper. So many algorithms are there, like in terms of the equations used. Okay, this is the research paper. You can see the equations. Based upon this, we can make the algorithm. This is the Lorentz model. Okay, and then tangent space. So we can devise algorithm based on these equations. Okay, here is the methodology used. Here is the methodology used by the authors. Okay, fine. Here's the methodology used by the authors. Okay, here you can see hyperbolic attention and aggregation, the equations for it. Okay, and all the experimental experiments results are being mentioned here. And they have applied their technique on first they applied their technique on benchmark data sets, small data sets like cipher 10, cipher 100. Okay, MNIST, these are the data sets over which they have applied their technique, their algorithm. So these are the benchmark data sets, basic data sets. So whenever you are preparing any model, whenever you are preparing any algorithm, it is important that you kindly try and test your algorithm on basic data sets or primary data sets. When you get the success, then you please move to other data sets. Okay, after getting success, then you can move to other data sets. All right, fine, this is how you can do. Fine. So I want to just highlight this part of the research which was discussed, and I mean to add some like understanding, like this is how we can approach to a particular problem statement if you are looking forward for novelty. A very good research paper, something to learn about. Now, coming to our project that we were doing, that is multiple disease prediction. In this particular code, we have reached till all the visualizations. Okay, fine. This is what I've told in the last session also. All kind of visualizations we have performed. Okay, which are necessary visualizations we have performed. Okay. Now then, after that, uh, after the visualizations, like we require important or relevant features by the help of which we can train our model. This is what we want. Okay, and I told that in case you are having so many features present in the data, we are not at all interested to train our model with all features. No, because they might be related to each other. That means they might be having the correlation, and because if they are having the correlation, in case, so like a model will be subject to overfitting. So we don't want the correlation between the features. That is why see here in the code, these are my continuous features. And I think in our data set we do have all the features as continuous in nature except the target, which is categorical in nature. So I mean to find the correlation between the features. Okay, I want to find the correlation between the features. Df continuous dot corr, correlation between the features. So if you are working on such kind of data sets, okay, and you are having numerical features, and it's mandatory to have a numerical feature in a data set, and in numerical also it is mandatory to have a continuous features. Mandatory. If you don't have continuous features, then what the sense of making, like what are you doing with the data set? It is mandatory that your data set should have a continuous features, because continuous features are only the features which are going to show you the relevant distribution in the data. So I do have the continuous features. All are related to medical terminology like glucose, cholesterol, hemoglobin, platelets, WBC, RBC. All these things are there. I find the correlation between the features. Correlation. I think I told in the previous classes also, positive correlation, negative correlation. That means if one feature is increasing, another feature is decreasing or increasing, what kind of behavior it is showing. So this is df.corr, and you can see that cholesterol is related to glucose with 20% correlation. Okay, then you can see WBC, white blood cells, is 5% correlated to hemoglobin. Okay, so that's a correlation. Some are negative also, like -4. That means if glucose is increasing, red blood cells are decreasing with 4%. That's negative correlation. It's inverse. So negative means not negative, it's inverse correlation. Okay, got it. So this is the correlation which we are getting for each and every feature, each and every continuous feature, and the best way is to plot the correlation. So here is a plot of correlation. In a very easy way, we can make a heat map. Heat map. So heat map will show you the correlation. Now we can use this heat map in our research paper. Okay, that we applied correlation on all the numerical continuous features, and we got it that this is the heat map, and you can see of features which are having high correlation. Like here I can see 36% correlation between body mass index and the glucose. Okay, then 30% correlation I can see between diastolic blood pressure and BMI, body mass index. Okay, so from image you will get an idea that which features are highly correlated, how much they are. However, the highest correlation or the threshold which we can fix, that's in our hand. Like if you say any feature which is correlated, showing correlation more than 70% or more than 80%, then we will consider them as very very highly correlated data features, and we will be dropping any one of them from it. We are not going to consider both of them. We are not going to consider both of them. And what's the reason? Well, the reason is, instead of What happens in model training? In model training we want model to learn, not not to memorize. We don't want the model to memorize, we want the model to learn. And if the features are related to each other, model will memorize, not learn. We want model to learn complex patterns in the data. That is what our goal is. But if the features are related to each other, model will not learn, model will start memorizing. Because why? Because if the feature f1 and feature f2 are related to each other, now if a model is able to capture the details of f1, model can easily trace f2. Model will not have to model will not have to put an effort, because both are related to each other. So model can capture f1, model can easily capture f2. It's easy, it's memorization, it's not learning. That is why we will be dropping f2. We are not going to keep this f2 in our list of training. Once what I can see here from the heat map, we don't have any feature available which is having correlation higher than 60 or 70 or 80. I can't see any of the feature. At most 36 I can see, 30 I can see, 25, 17, 15. This is what I can see. But there is no feature which is highly correlated among the other features. Okay, fine. So what I did is huh, I am making disease and the rest of the features to have a group by operation and taking the mean of all the values with respect to the disease. That's what I am taking. Okay, so we do have anemia, diabetes, healthy, and other 4, 1, 2, 3, 4, 5 kinds of diseases, and these are the mean values for them. These are the mean values for them. Okay. So group by taking mean and pivot table. Just making a table in which I am putting diseases on the index position and rest all the features in the column. Just to show the relationship between the diseases and all these values, either by taking mean, either by taking max, either by taking minimum, whatever you want to do, we can. This is what we are doing. Then later on, I started with the training part. Okay, because I haven't found any features which are highly correlated, so there is no sense of dropping them. Okay, let's keep all the features, all numerical features in a list. Now, what to import here? What to import? I am taking label encoder. Why? Because my target, the disease, is in object type, that is written in a text format, so I can do the label encoding for it. Okay, convert it into 0, 1, something like that in some numerical values. So that's why I'm taking the label encoder, and this is how you can encode your disease values. Label encoder, so it will be 0, 1, 2, 3, 4. That's the label encoding. Because the disease is categorical in nature, it is having object type values present in it, so you need to encode it. All right. So that's the way you can do the label encoding for the disease. Okay. So on x-axis, I will take all the features which are continuous or numerical, and on y-axis, my target is disease. Very simple way. I'm doing this part. Okay. Okay. Got it. That's what we can do. Okay. Fine. Then we can divide training, testing. That means the data into training and the testing. We are considering test size as 20%, and we are taking y in terms of stratify means I want to tell you something. Okay, whether I have used oversampling also. Yes, random oversampling also I have taken. Hmm. What is this stratify? Well, you are having five classes present in the data. Five classes you are having present in the data. Let's say A, B, C, D, and E. Five categories are present in the data. While dividing the data, I want every entry or the elements of these categories to be present in training also, to be present in testing also. In case it happens that category E values are less in number or very less. Okay, it's if it's very less in number, and you are doing training and the testing division, and E, because it is very less in number, is left out during the division. If it is left out during the you're dividing the data, so your model will be trained on only these, and while testing, if you ask for E, your model will fail. It will give you the wrong answer. Not right. Therefore, we use stratify. Stratify equal to Y. So whatever be the target is, okay, we need to stratify. That means we need to ensure that some portion of E should be present in the training, and then it should also be present in the testing. That's what we ensure. Doesn't matter that it's number of records of er less, but we have to ensure that it should be present in the training and testing both. It should not be eliminated. That is why I use stratify here. Okay, apart from that, there is one more parameter called as random state 42. Random state 42 means you need to fix the data division. Fix the data division, fix it, because you will run the code 100 times. Run the code 100 times. This will happen, sir. I run the code for first time, I got accuracy 96. When I run the code next time, I got the accuracy 95. Why this happens? Are same algorithm, same data, everything is same. See, the point is, if you are using train test split, this is auto splitting. This is auto splitting. Automatically, the data is splitted into training and the testing part. So maybe for the first time when the model performed the splitting, when you did the data splitting, so other images were present, or other features values were present in the training part. And when you again run the model, then it happened that training was splitting was different. Okay. So if you use random state 42, it's going to fix the splitting part. It will not change again and again and again. So this is something, a magic number, random state 42. Okay, got it. So we are going to use this random state 42 here. All right. And after that, we are going to oversample, or we need to balance our all the classes now. So oversampling will be required here. Okay, so balance your data. Again, one of the important step in pre-processing. Still, we are not going to hand over the data to the model. So oversampling. So you need to oversample the training data. I told in the last sessions also. Here also I'm telling that you need to oversample your training data. Okay, and then you need to scale your training data along with test also. X train should be scaled and X test should also be scaled. Scaling is important. So these two things are very, very much important. Kindly fix the number of kindly fix the number of classes. Okay, there should not be imbalancing in the data, so perform oversampling. Okay, and after doing oversampling, you need to perform the scaling also. Okay, you need to scale your data also. Okay, we never train a model with data where some of the features do have high values, some of the features which are having low values. I explained you the reason in my previous classes. So scaling is required. I need to convert, I need to transform the data in some particular range, so that will be a flexible for my model to interpret, because model will do learning, and during learning, if your data is not scaled. So I already talked about variance problem or the variance issue. The variance problem or the variance issues was a feature which is having high variance, that will be learning more, that will be contributing more in the model development. And the features which are having less values, whose variance is less, that will be contributing less. So their scope is over. Okay, and it may happen that model will not show the stability. Okay, therefore, this line is very much important. Okay, this one, scale. So fix the imbalancing, scale your data, and now give it to the model for training. So I'm using logistic regression here. It's a classification model. So using logistic regression here. And after once my model is trained, then I can check the predictions from the model. I will print the accuracy, I will print the confusion matrix, I will print the classification report, all these things I'm going to display. Obviously, like this is a classification, no? So for a classification, we require accuracy and confusion classification report. This is the metric which we use for a classification. Okay, got it. So the results are as follows. See, the data set was very less and the model is very like good. So accuracy is obviously for 100% for this case. And for other models also the accuracy will be 100%. Because the data set is very less, and it's already having out of 2300 something or 400 something, 2200 are the duplicates. All right, so we are just using this code, we are using this project as for our reference purpose. Okay, this is for our reference, we are using this particular code. Okay, got it, understood. So with logistic regression, I got this much accuracy. And then I tried other models also, like support vector classifier, random forest, decision tree, neural network, multi-layer perceptron. Neural network also I tried. And XGBoost also I tried. So this is my second model. Two, three, four, five, six models. This is my six models I've tried, including logistic. So with support vector machine, these are the hyperparameters. Okay, we'll do the hyperparameter tuning also. I'll explain you that part. So support vector machine, SVC, kernel. I'm taking RBF. By default, it is RBF only, radial basis function. So kernel is one of the important parameter in support vector classifier, which will let you know how to represent a data, how to classify it. Kernel will be a hyperplane which is cutting the data. So RBF, radial basis function, it's like this. RBF looks like this, radial basis function. It's look like this. RBF, RBF. We can have a linear kernel also. If we are having binary classification, then we can use a linear kernel. We can use sigmoid also as a kernel. There are different kernels present in the support vector machine. We can use them and see how results are coming. At the moment, for this I am taking RBF, random state 42. Probability not as much important for us. Random forest, taking 100 decision trees to perform the classification. Decision tree doesn't matter, random forest, random state 42, random state 42, random state 42 is here. Whatever the model will do, that will be fixed. XGBoost, okay, there are some parameters again. like binary, it's going to use logistic to perform the classification, and it will evaluate the log loss. So here is a parameter for XGBoost, which I am using here. Okay, general. Then I am making a multi-layer perceptron, a neural network. In neural network, I am saying that we are going to use 128 and 64 hidden layers size. That means number of neurons should be 128 and 64. Activation function should be relu. Adam will be the optimizer, and we are going to iterate it for 300 times. Okay, that is something I selected to make the neural network in a easy architecture, very easy architecture. Okay, and then here is what, after training I got the results. SVC again 100%, random forest 100%. Okay, decision tree 100%. All model will give 100% only, because data is not that much hard. No? Data is very easy, so all the models will give me 100% only. These are the results: 100% accuracy on every model. Then comes the hyperparameter tuning that was asked in the previous class also. Sir, kindly include hyperparameter tuning here. Okay, though I already got the good scores, but still I'm incorporating a code of hyperparameter tuning. Now, when to do hyperparameter tuning? When you are going to do the hyperparameter tuning? You have already seen the entire project, every step from data visualization to the model part. Models used in the project are logistic regression, decision tree, random forest, XGBoost, multi-layer perceptron, okay, support vector classifier also. All these six models are used. Every model is giving 100% accuracy. That is not subject to what we are going to put. For this data set, it is giving, which is having so many duplicates and only unique 200 or 300 entries presented. Very small data set. For small data set, you are going to get this much accuracy only. What to do? Anyways, ignore that part. The question is when to do hyperparameter tuning. Hyperparameter tuning. Okay. Now, anything from your side when you do hyperparameter tuning, or what's the question you do have related to it? Okay, I want to know from your side that what actually you want to ask in hyperparameter tuning, when you are going to do that, and what's your query related to hyperparameter tuning. I want to know where you are struggling in hyperparameter tuning, and also yes, in research papers, we need to include this part of hyperparameter tuning. We need to include this hyperparameter portion, telling that we have applied these hyperparameter, then we got such results. But the question is when, how you are going to do, in which conditions, like where you are stuck to apply hyperparameter. Anything you want to say? You applied, where you stuck, what happened? Can I know? Do you have anything to say about it? Yes. I hope you are aware it's been used in the papers. You might have also used in the papers. But can I know what exactly it is? What's your idea? What's your thinking on it? Yes. Well, according to my perspective, let's say, yeah, anything, any comment, la, please, sir, sir, you please tell. Okay, yes, I'm telling, madam, I'm telling. From my perspective, I'm telling that when to use and how to use. I will show in the code. Well, let's say you got an accuracy of 92%. Okay, you use a model, you got an accuracy of 92%. Okay. Now, there is a thought in your mind that I can improve accuracy using same model only. There is a chance. There is a chance that I can improve the accuracy by using same model. Currently, the parameters which I am taking, they gave good result. They gave me 92%. But still there is a chance that I can improve 92 to 95% accuracy. So can I do experimentation? Experimentation. Because in every model, if you see the official website, you will see, let's consider logistic regression. If you see the official website sklearn, in logistic regression, you will be getting 10 to like 10 parameters. Let's say 10 hyperparameters you are going to see. 10 different hyperparameters you are going to see. Out of these 10 parameters, at least 3 or 4 hyperparameters which are important. So according to your thinking, that I have a chance to improve the scores if I can tune these hyperparameters by putting some values, let's say sometimes 100, sometimes 200, sometimes 500, sometimes 1000, and I will see that if I change the value of these hyperparameters, and what kind of data you are going to take here, what kind of data, this is my data. I will take a sample from my data. I will take a sample from my data, and I am going to apply the model with these hyperparameters and see what results are coming. There is one more thing here: cross validation. Cross validate. What's mean by cross validation? Well, for example, I took a particular sample, tested the model on these hyperparameters, then I'm going to submit this back again. Then I will pick another sample. Again, I'm going to test the model on these. I need to cross verify that if I took this sample, how much was the results, and I took this sample, how much is the result. This is called as cross validation. Okay, so you are taking different parameter values, you are taking different samples from the data set, you are training your model on it, you are then cross validating that okay, with this parameter, with this sample, this much value came, what was the value, what with that sample, how much we got it, let's cross validate. And by doing so, by experimenting with different samples of the data, by experimenting with different parameter values, now you will get an idea that my model can perform better on this hyperparameters. Hyperparameters. My model will be good in these hyperparameters. And when I told you to do this tuning, when you when you have a belief that I can progress, Now, if you get a 60% accuracy and you are doing hyperparameter tuning, then what is the sense? Can 60 be converted into 90? No. Here you do not have to do any hyperparameter tuning. Okay. 60 can be max converted to 65. Still you are in underfitting phase. I told you when you can apply hyperparameter tuning, you are having 92% and you feel I can reach to 95 or 96 by doing some experimentation. But if you are already struggling with 60, you can't reach to 90. In that case, what's the sense of hyper? No, I don't prefer any tuning in that case. In that case. Got it. So in the code I incorporated hyperparameter tuning also. Here you can see. Okay. Stratified k-fold splits 5. Divide the data into 5 parts and also shuffle them. Shuffle the data points. Stratified k-fold splits 5. You can it's your perspective of changing this. You can make 3 splits, you can make 7 splits of the data. Shuffle the data, split the data. Okay, then you have to apply cross validation. Okay, fine, that's what you need to do. Then you need to apply the cross validation on each and every model. The models which are being considered as all these models which I have already applied. Okay, all these models only support vector machine, and these are the models. Okay, logistic and all these models will be applied, and here are the results coming. Obviously, it's going to be 100% only. Previously, also they came as 100%, so it's still the same. So you can do cross validation and test your model. That what results they are giving. You can change the hyperparameter values also. Currently, I have already defined my hyperparameters here. If you check, already defined my hyperparameter. These are the hyperparameters: kernel, probability, random state, and number of estimators. You can change them. Add more hyperparameters which are relevant, which are important. For example, in random forest, number of estimators are 100. There is one more hyperparameter. You can include depth up to which your decision tree can get explored. Here also you can define the depth, one of the important hyperparameter in random forest and decision tree. Okay, so 3 to 4 hyperparameters are important in every model. So you can put the hyperparameters, and also we can prepare a set. Like currently, I am taking number of estimators 100. Next time I will take 200. Next time I am taking 300. Next time I am to take 400. So you can take a hyperparameter and prepare a set of different values for that hyperparameter. That's also possible. That will be hyperparameter tuning, and this is cross validation. This is cross validation, the one which we did. We are cross validating our model, okay, with on different subsets of the data, and still we are reaching 100% accuracy. But you keep this code as per your working, okay, as a reference code. Meanwhile, in our research, we had ablation studies also. An ablation study evaluates how removing or altering key components affect the model performance, helping justify why each component matters. Okay, now I want to know from your side, like I think you have submitted the papers on that day. Madam was also saying that we have added the ablation study. Yes, madam. Any like inputs from your side? That's what the ablation means. That removing or altering any component affect the model performance. You are getting good performance from the model if you remove anything from the model. Okay. So You can ablate along any of these. You don't need all. So common ablation dimension, for example, according to your data, because we are doing the classification, feature set, all the features without group A, without group B, model complexity, shallow neural network or deep neural network, fewer trees. So we can do the changes. We can do the changes in the architecture. We can drop some layers. We can drop some components and then show that how results are affecting. So if you have made some layer from your side, if you made an architecture from your side and you have put some components in that architecture, you trained your model, you got the good results from that, and next time you drop that. You drop that layer and then again train the model and see what results are coming. Then justify your answer that okay, in our ablation study, we found that no, that layer which we have built, no, it is very much important. Okay, we have justified by doing ablation study that removing or altering the key components. My layer was a very key component. Because of that only I got this much result. Else I am not going to get that much result. So ablation study will be added. Okay, that's what I have incorporated here in my code also. But I just want to make sense by telling you what the ablation study is. Okay, and like how we can include in our research paper. Fine, got it. Now, yeah, yeah, anything. The reviewer appreciated, yes, madam, obviously, reviewer will appreciate. Again, it's a part of justification, no, madam. You have created something from your side, and then when you are dropping that and comparing with what you did, and if that thing is not present, you compare, and if there is a compromise in the results, then obviously you will tell that I am in the better position. This is the reason my research is successful. So you can't ignore my component, my layer from the architecture. So that's the reason ablation studies are now included. Okay, and that's what mentioned in the code also, that ablation study evaluates how removing or altering key components affect the model performance. So we need to justify that each why each component present in my architecture is important, mandatory. Now ablation. So far we did comparison of other model with the previous models. That is okay. That we need to include in result analysis. But this thing also. Okay, got it. Fine. Now I think you told that, sir, we already had a session on overleaf and like we did experimented also. Fine, not an issue. Not an issue. I need to tell about the overleaf and some basics of overleaf, like I guess which you have already covered up. Okay, here is my overleaf. Here is my overleaf. All right, fine. Here is my account on the overlay where we can do the code in the latex. Okay, fine. And like the latex one, that means it's a markup based type setting system like a Word. And you can write plain commands, text file. There will be text file. Now that can be converted into beautiful PDF that will be accepted in all the journals and the conferences. Okay, so you focus on content, computer handle the appearance. That is what the latex is. So it's a markup based typesetting system. Okay, text engine to make a beautiful PDF. And the challenge is, in your research paper you need to add maths, tables, scientific content, references, all these things. So if we work on latex, the advantage is we can make all these things fair. and templates are present in the latex. Like how your the minimal thing which is required is document a class, begin the document. Hello, this is my first document. End the document. I think you have already practiced such things. Create a document, begin the document, end the document. Whatever be the content, write in between the document. Okay. And then if you want to add the packages, you add before the document, before the beginning of the document. Okay, like use package graphics for images, use package maths for doing maths. We can set up the title also, author name also, date also. Everything we can use in the overleaf latex. Title block, like make a title, begin the document, then make the title, then end the document. So we can add a title block also here. Okay, whatever be the title, just write it. Text formatting, okay, something bold. Text to BF, make bold, make italic. So bold font, italic font, all can be done. If any other word you are interested in formatting. Images can be added, like use package graphics path, that's optional. Okay, this is how you can add an image. Begin the figure, centering the image, include the graphics, write the caption. This is the name of the plot, end the figure. Okay, that's what you can do. Adding image. Then list also can be done. Begin item size, first item, second item, end the item. So this will be unordered bullet list can be made. Ordered numbers if you want, then enumerate. Use enumerations. Then it will be numbering the list. And maths like in this way. Dollar E M C to the power 2 again dollar, this is E equal to MC square. For that, you can make begin equation E equal to MC square, label Einstein, end the equation. Basic structure for the sections like introduction, background, detail, you can make section, subsection, subsection, paragraph, all can be done. Table if you want to make like table H, begin table, centering, begin tabular, H line. Okay, A, B, C, all these things. Yes, no, whatever you want to fill the entries and end the table. Give the caption, give the label, table of contents. Like you can write slash table of contents. So packages which are important are you have I think gone through for the 2 days you did all some work on the overleaf latex. So maths, symbols, graphics, geometry, hyperlink, hyperreferences, units and the numbers, book tabs, all these things are important. Most useful commands are these only. Most useful commands are these in the overleaf. Okay, got it. Fine. Now let's say I am working on a project that is deep fake detection. I'm working on this project, deep fake detection. And whatever be the basic elements of overleaf I have learned, I want to make a research paper. My coding is over and all results and everything is over. So let's check. Here is the paper, deep fake detection paper. All right, we don't work on like on other tools. We work on this overleaf. Okay, so on that day too I'm going told that I will be getting the suggestions. I'll be getting the suggestions from the overleaf, and whatever I did I can change the English based upon it. All right, If you make, let's say, if you make a new template, if you make a new project, blank a project, I would say, I would say your multiple disease detection. Okay, new project, multiple disease detection. All right, multiple disease detection, create. So what we are getting from, like, initially what's written here? Okay, document class, it's an article. Graphics, we are going to use it for inserting the images. Title of my research is multiple disease detection. I am the author. Here is the date. Okay, if I don't need the date, let me empty it. I don't need the date. Here, from here I can begin the document, and here I can make the title. My section is introduction, and I will end the document. So I'll keep on adding the elements. I will keep on adding the elements, and then I can compile it. Whatever be the changes I am going to make, I will compile it. Okay, so change the title, add the authors, date I don't require, whatever be the packages which I need. Either I need to make a table, any maths. So whatever be the packages need to be required, I'm going to add all those packages in my this overleaf template. Okay. Then I will be writing for the introduction. This is the introduction. Hello. Okay. Let's write introduction. Disease. Disease detection. Detection. Detection using machine learning. Disease detection using machine learning. Let me recompile it. So whatever be, like, in the introduction, you can add, then you can make more sections, you can make subsections from your side, keep on writing. Okay, you can proceed for this. Meanwhile, I have one template from my end. Let's say I'm working on a project, as I told, deepfake detection. This is a project on which I'm working. You tried from your side, you tried from your side of making the content. Okay, you tried from your side making the content, and okay, let me refresh it. Let me refresh. Okay, all right. And I think you have written the sentences. You have written the sentences from your side, but still, is there any plagiarism coming or something? You can see on the overleaf there are yellow marks present here. Whenever you made something on the overleaf, na. Okay, so let me put a right click. Nowadays, what I wrote, nowadays, what suggestion I'm getting. So I'm not going to accept the suggestion. No, I need to do the hard work from my side. Okay, if you say accept the suggestion, no, that's not the thing. Nowadays, what the overleaf is suggesting, today a lot of fake content is circulating on the internet. Okay, so today a lot of fake content. So write according to that. Today, now change. Today, a lot of fake content is circulating. Today, a lot of fake content is circulating on the internet, not over, on the internet. Okay, today there is a comma. There is a comma. Got it. So I took a suggestion from the overleaf, na, and I changed my sentence. See, whatever the previously created was from my side. I created this sentence. But if there is some grammatical or some mistake is there, so I can overleaf can help me. Such a content looks so real that its a detection, classification, okay, comma is there, and removal is difficult. This is because, this is because, okay, comma should be here. Comma should be here. This is because deepfake technology uses deep learning algorithms which creates highly realistic fake videos. Not only it threatens, okay, not only does it threaten, okay, not only does, does it threaten, not only does it threaten the reliability of online information, creates, okay, create, not creates, create. Not only does it threaten the reliability of online information security, but also it can, but okay, it can also easily perform, remove this part, it can also easily perform manipulation on faces and voices. It can also, I already did it, systems, it can also, see, this is how I am changing, this is how I am changing. Whatever I think is feasible to change, which is required to change, I'm changing from my side. Okay, deep learning algorithms which that, so it will give you the suggestions, and accordingly you can change the words. Okay, now again, deep fakes such as voice cloning, text to speech, voice conversion, sound editing, language translation, segmented images can be created easily created, can be easily created using low cost technologies and mobile apps. Some of them are face app advanced frameworks, not like such as dynamic identity recognition networks and vocoder based voice synthesis systems. As a result, deepfakes are now become a mode of spreading fake news, false news, false news and misinformation by different groups, including automated accounts, political actors, and online manipulators. So you can see I've changed the paragraph, the words which are highlighted in the overleaf, and accordingly I'm editing my research paper. Okay, so I am in this section of introduction. When you create like the research paper, you will automatically getting the introduction section in the overleaf, and you need to simply write as usually you are writing. This is the flat English which you are writing. You are going to get the suggestions from it. Now please let me know what's in your mind related to it. Please let me know what's in your mind related to this particular uh, overleaf part. Yes, what's in your mind related to the overleaf?
So we may have to try that and see it's the.
Ma'am, yeah. See, if you want, I can share you the overleaf content also. Okay, I can share you the overleaf content. Fine. Okay. Let's see. Although
No,
there
no.
are many.
First, we would like to just listen to you and then try it ourselves.
Okay, ma'am, I will share you that content so you can also practice side by side with me.
Yes, sir.
All right, fine. So I do have a content. If you want to practice, yes, I do have a content for you. So let's say Control A. Okay, let me share this file, madam. Let me share this file to you. Okay, Control. Okay, document class. Let me mail it to you, madam. Okay, fine. So here is a file. Multiple disease classification latex file. Okay, so document class D. Document class. I mailed it, madam, this file. So now, ma'am, I think you can share to everyone. Okay. And
Yeah, yeah, I'll do it. I'll do it.
they
Give me
can
some
open
time.
their overleaf, madam. So we can
Yes,
practice
yes.
side by side, not an issue. So not this file I have shared, the fake one. I have shared another file, the one which is multiple disease classification, which we have made. I have shared that thing. So let's try that. Let's try that one. Okay. So I request everyone to open their overleaf. So everyone should open their overleaf. I think everyone is having the account and did perform the editing in the overleaf. Okay. So whatever be the file I have shared, okay, like multiple disease prediction. This is the new file which I have created. Okay, this is the new file which I have created. All kindly create a new file over this overleaf. Here you are getting the article graphics. That's what you are getting. What is present with me in the document class? Let me tell you. I do have these packages: graphics, listing, maths, book tabs, float, caption, sub caption. All these things I am having. Okay, so graphics for figures, for code listings, for mass equations, for tables, for floating point environments, for captions, and for subfigures. That's what I'm having in the overleaf. So I request everyone to open this doc file and they can practice. And these packages are the minimum packages. We can add more packages as per our requirement. That is what we can do. Okay, got it. So, madam, all are working, madam. I've shared the file. So please refer this file to everyone. Okay, shared. Okay, shared to everyone. Fine. Shared to everyone. So like you can take, or let's say, first let me take the required or the necessary libraries or the packages and put it here on the top. These are my required libraries or the packages. Okay, got it. Then I will give a title: multiple disease detection using machine learning techniques. techniques Multiple disease detection using machine learning techniques. This is what I will give. Author, well, you can set from your side a date. Okay, you can make it as empty right now. All right, fine. Multiple disease detection using machine learning techniques. We'll be doing the recompilation in order to check things are going well or not. Okay, so this much setting you do. Okay, fine. Then title, I think make title, it's been there in our document. Make title is there, let it be. Introduction we can give from our side, but let's say I am going to add a section that is research methodology. This is the entire research methodology section I am putting in my research paper. Subsection evolution study. Control C. Till here, I am taking before result analysis. I am taking the entire one. Okay, and let me put it here back. Okay, let me put it here. Okay, so what I'm going to do is research methodology. I can get some suggestions in yellow marks. You can see the suggestions. So, in research methodology, this study employs a comprehensive machine learning pipeline for predicting multiple diseases based on blood biomarkers. Well, as I told, you need to write in a simple way. Okay, in a very simple way. So, this study employs a comprehensive machine learning pipeline. Better in this section, in this section, a comprehensive study of machine learning models, a comprehensive study of machine learning models for predicting of, okay, comprehensive study of the machine learning models for predicting multiple diseases. Okay, see here, the is removed and biomarkers is presented added. So in this section, a comprehensive study of machine learning models for predicting multiple disease based on biomarkers is presented. Is presented. So in case if you took a help from AI, or if you are mistaken in something in writing related to the language, or some word or grammar, we are getting the suggestions, live suggestions. Okay, in front of you I am doing. And again, I got some suggestion. In this section, a comprehensive study of machine learning models for, no, no, no. A comprehensive study of machine learning models is presented to predict multiple diseases based on blood biomarkers. That is one of the good line they suggested, rather than writing a big line. So in this section, a comprehensive study for of machine learning models is presented to predict. Is presented to predict. I'm removing this, multiple diseases based on blood biomarkers. That's what I changed according to the suggestion. Now there is no yellow line. Okay, that's correct. Fine. You can check. I'm putting here in the comment also. Okay. Rest, what happened? The methodology is structured to ensure reproducibility, robustness through ever. Okay, no sense of writing this line. Remove it. Remove it. It includes data handling, pre-processing. It includes data acquisition, acqui, acquisition. It includes data acquisition, pre-processing, remove handling part, pre-processing, model selection, training, hyperparameter tuning, cross-validation, and ablation studies. Now remember, the process leverages. Don't use this word leverages. I don't personally recommend this word leverages. This word is specifically used by LLMs, AI tool. This process use use Python, Python remove rest. This process use Python programming for implementation and Jupyter notebook and Jupyter notebook as an environment uses. See, I'm also telling that what could be written in the what's the opening of the research methodology. How to open the research. You can introduce the models also. In this section, a comprehensive study of machine learning models is presented to predict multiple disease based on blood biomarkers. The models used are logistic, decision tree, etc., etc. However, we are going to later on add them. But if you want, you can put it here. So this is the research methodology I created from my side. Here it is, research methodology. If you want to add, and if I'm something mistake related to some sentence or some word, you can let me know. Or if you have any suggestion, please let me know. Any suggestion, please. Here is a methodology in front of you. One para I added. So, previously we were struggling in making the paper. I'm making it in front of you. I did explain the entire code, data, code, everything. I'm making paper, I'm making methodology in front of you. Now tell me, where is the struggle? Please tell me, where is the struggle? Yes, madam. Is anything you want to say? Then, subsection. First is data acquisition and exploratory data analysis. So, create a subsection. So, there is a section research methodology. Now, you are creating a subsection. All should be written in a curly braces. Okay. Therefore, the data set was sourced from. Now, either you have taken the data set from Kaggle or any other sources, whatever be your data set link, na, you can mention here. Okay, you can mention here whatever be your data sets are. So currently the data set is sourced from, let's say, from Kaggle, because I took that thing from Kaggle. So the data set is sourced from Kaggle containing containing 2351 entries with 24 continuous features. The dataset was sourced from Kaggle, full stop. It contains this much number of entries, 2351. It contains 2351 entries with 24 continuous numerical features. Continuous numerical features, full stop. Example, glucose, cholesterol. No, no, no. This is not the way you are going to write it. No, that's not the way. Not example. That's not the way to write. Okay. That's not the way to write. And don't split the data set. It's correct. The data set was sourced from Kaggle. Link is not presented currently with me, so I have kept it nothing. It contains 2351 entries with 24 continuous numerical features. Some of them some of them are glucose, cholesterol, hemoglobin, platelets. Uh, Approximately 1 in 8 people have corpuscular hemoglobin. This, okay, that's what they are saying. That's not required. That not our perspective. We are just mentioning the name of the features. Okay, we are just mentioning the name of the features. All right. So some of them are glucose, cholesterol, hemoglobin, platelets, WBC, RBC. Okay, the names. Not entire. You can write. Not entire. You can write. Some of them are glucose, hemoglobin, platelets, WBC, RBC. Rest delete. Then insulin, BMI, etc. You can keep. Okay. Still, some of them are. You can remove more. You can have some of them are cholesterol, hemoglobin, till hemoglobin, WBC, RBC, till remove here, and one categorical target variable disease. Okay, cells, small c. So the dataset was sourced from Kaggle. It contains through 2,351 entries with 24 continuous numerical features. Some of them are glucose, cholesterol, hemoglobin, platelets, WBC, and RBC. There is one categorical feature present in the data set that is our target. That is our target. There is one categorical feature present in the data set that is our target. Present in the data set, call it a disease. Mention here. Present in the data set, it is our target. It is our target. It is our target. There is one categorical feature present in the dataset disease. It is our target. It comprises of it comprises of five categories. It comprises of five categories, comma, namely healthy, diabetes, thalassemia, anemia, and one more name. Namely, like this. Okay. Let me recompile. See your content of your content for in a paragraph h box too wide in paragraph line number 25. Okay, not an issue. So here you can see what we have created using overleaf in paper writing. Okay, now eds steps included. Eds steps, we need to change the sentence. The steps performed for EDA are inspecting the dataset dimensions, inspecting the dataset dimensions. Okay, not in this way we are going to write. Not in this way. If you need to write in bullets, if you need to write in bullets, we got This latex notes. Okay, we got this latex notes. Is something we want to write in a list format. So this is what we can take. Okay, if it is an ordered or number, then we can take this thing. Begin enumerate and then end enumerate. Alright, so control C, let me take it here and let me put it here in the latex part. Okay, so the steps performed for EDA are control V. Okay, uh, this one first is data set inspection, data set dimensions inspection, dataset dimensions inspection showing 2351 rows with 25 columns. Full stop. Remove this line. Second, checking the duplicates. Checking the duplicates. Control C, you can use. Checking the duplicates. Checking for duplicates. It has found that there are 2286 duplicates were present in the data set. Full stop. Then again, next item. Add the item slash item. Control C, put it here. Control V, item. Okay. Verifying missing and null values. Remove this part also. Verifying no missing values using, so just use, take it here. Verifying verifying duplicates or missing values. Okay. Checking for duplicates and found that okay, duplicate already checking for verifying missing values. Duplicate we already did. Okay, were present in the data set, were present. Checking for duplicates present in the data. Checking for upon checking for duplicates, upon checking for duplicates, it has found duplicates were present in the data. Upon checking for duplicates, 226 upon upon checking for duplicates, it has found upon checking for duplicates, it has found 2286 duplicates were present in the dataset. Then next step, verifying missing values. Okay, verifying missing values. Like this is what you can make. Then analyzing class distribution. Okay, control C. Analyzing class distribution slash item. Analyzing class distribution. Then statistical summary. This is what you can put. Statistical summary. Control C. Let me remove this part also. Remove this part and like here slash item. Okay, statistical summary display. Something which we can write from our side. Okay, let me recompile. See, points are coming. The steps performed for EDR: first, dataset dimension; second, upon checking the response, this is verifying the missing values, analyzing the data to statistical summary. So this is live on practice in front of you. How you made a section, how you made a subsection, how you are entering the content in this section or subsections, how you are making the points, and you are getting the suggestions also. You are getting the suggestions also for it. Okay, you are getting the suggestions also for them, and accordingly you are changing it. Then visualizations using mat, don't take these things into, we are not going to add the libraries part in the research paper, that what libraries you use, matplotlib, c1, that is not important in the we are not going to add the libraries. Okay, we are not going to add the libraries. Okay, got it. Visualizations, not the word employed. Visualizations were drawn or performed, but not explicitly shown in the notebook. Okay, don't like this line. Something which is bad, you can remove it. Okay, so I made the initials, I made the subsection, I made the EDA for you. This part, enumeration part, how to add the items present in the node, like in the research paper. Then you can, again, in data pre-processing, same steps can be mentioned. Steps can be mentioned. Pre-processing is a pivotal, was pivotal to prepare the data for modeling. You can make any of the word highlighted, bold. Okay, so text to BF, text to BF. This is what you can use, text to BF. All right, but it's better you incorporate item. Okay, incorporate item, then you can put this thing into text to BF. For example, if I'm using text to BF, Control C. Okay, text to BF. Let's say Control C, and I'm going to put it here. Control V. Okay, and then I'm putting curly braces. Okay, curly braces. That's what I'm trying to do. Let's see what happens. Recompile. Okay, so here you can see point number one, data set dimension. This word has become bold now. So point, then you can use colon. You can use colon marks here. Let me recompile again. So bold also, point is getting bold also. Points are also making, and you can write the lines. It's easy. If you are making the documents on doc files, it's better now. You can make the documents on the latex, on the overleaf, and this is live working in front of you. What are the elements of overleaf? I don't know whether, like, you have experimented, madam. You have done the experimentation in the 2 day workshop you performed previously. Any paper or some content you have prepared with that overleaf?
No, sir. I mean, this is the first time we are doing it,
Okay, all right. So
and it needs registration and all. We just did it now.
okay, okay. So, like, if you haven't done, this is something which I am
Yes.
doing in front of you. Okay.
Yeah, yeah. It is quite easy, sir. It's quite easy.
So you can change, you can do the changes from your side, and accordingly, content can also be changed, and like
Suggestions also can be
suggestions also
taken.
coming and all this. Don't so see if any of the suggestion came, so like don't accept. Okay, like don't take it as an accept, else this is not paid. Okay, we are not paying to the overleaf part. Whatever we are doing, we are making as free. So the thing is, we have to do the changes from our side. Don't accept it. Okay, whatever changes coming, do it from your side manually. All right. So,
Yes, yes, sir.
and for example, besides, not the word beside. This is other than. Other than. Okay. Other than. All right. So this is how you can see. Models were trained on the oversampled. Okay, it's correct. Cross validation key for evaluation study results were compiled. The results were compiled. The results were compiled. And here is the end of the document. Okay, got it. So, like, it's one of the use case I showed you, and what we have learned here, we have learned about, see, about section, subsection, text bold, then making items like in points, in numbers. That is what we have learned. Now, if you want that, sir, how we can add the images also in this particular file? If you want to add the image and we need to format those images or some table also, if you want, okay, let me show you that. I have the templates available with me. Let me show you that how to add the images. For example, here is one of the code. Here is one of the code. So if you are available with the images now, if you are available with the images, let me recompile. If you are available with the images, you can upload the images here. See here. You click on upload. You click on upload. Okay, fine. Here is the upload option. So we did the code. Let's say we did the code. Here is the code, and images are available with us. This is the image. This is the image available with us. All right, that's why I told on the last days that if you are available with the code, convert it into doc file. And how easy to convert it into doc file? I opened the Google also, and I mentioned you there is one website called as Vertopal. So you just search on the Google IPYNB to doc. You will get that website Vertopal. So you upload your code on the Vertopal in that particular website. Then your code will be converted into doc, and it will look like this. Into document file, it will look like this. And once your code is converted into doc file, then you can save these images. Save picture as. Okay. So you can save in any of your respective folders in PNG format. It is portable network graphics, portable format. And then later on, you can on the overleaf info, upload, select the files. So you can upload your PNG images.
And similarity is 3% actually. Ah,
All right, this is what we can do. Select the files and upload the files here in the overleaf. Okay, so I have added pie plot, counter plot, hitting words. All the, see, you can see the plots here. You can see the plots I have added. All right, I have added. You can see the algorithm also, which can't be made on the doc file. These algorithms can't be made on a doc file because I have incorporated more packages here. So such algorithms can only be made on overleaf latex. Okay, well, okay. Let me first explain you about the image part because that is important. How to add an image? Let me tell you about that. See, here it is. Here it is. Begin figure. Begin figure. Then okay. On latex notes also we have done this part. Begin figure. This one. Similarly, I am doing here also. Begin figure. Okay, sub figure because I need to make a sub figure. There should be two images. There should be two images, so I'm adding sub figure, else I will not make a sub figure. But for two images, I need to make a sub figure. Centering again, it should come at the center. Okay, it should come at the center. Include graphics. Width
ఓకే
should
మ్యామ్. ఎక్కడ ఎక్కడ అప్లోడ్ చేయాలి దాన్ని?
okay, and the name of the plot which you want to add. So here include graphics. Okay, in the include graphics, you can add your plot. The name of the plot is countplot.png. So we can just do here. Your plot name should be added. So let me copy this code. Control C. Let me copy this code, and let me go to multiple disease prediction. Here, let me go to multiple disease prediction, and in pre-processing, let's say after this point, before pre-processing, after this, let me add a plot. The name of the plot will be count underscore plot dot png. This plot I want to add in my research paper. This plot I need to add in my research paper, count plot dot png. So I need to first save it. I need to first save it. Let's say this is the image, save as picture, and I will be taking it here, count underscore plot dot png is already been there, it's already in dot png. Okay, and then what I'm going to do, okay, select files. I'm going to select files. So I already added count plot png here, so I will upload it. Okay, this is uploaded, count plot.png is uploaded here. Now I have, in my code I have already added, so count plot png, and here I will write count plot for labels. Let's say I'm writing like this, count plot for labels, and let me recompile. See, plot is added. Okay, plot is added here. Okay, count plot is being present now here. Okay, got it. So what I did here, what I did, just only this much. This was of the code which I explained is present, and I added my uploaded and added my plot. You can add other plots also, and for making the subplot, I have shown to you that you can make subplots also. One plot nearby another plot. You can change the width. For example, the width is 0.7. Okay, let me make the width as 0.9. Let me recompile. Okay, size of the plot become more. By changing the width, it has become more. And let me change the caption. The caption is, okay, caption is figure 1, uh, count plot. Count plot for labels. Okay, I have changed the caption. This is count plot for labels. Figure 1, count plot for labels. So in you are making exactly the research paper. And why to struggle them? What's the matter of struggling? So you have learned about this coding, this validation, hyperparameter tuning, and all I told. Okay, and in fact, the overleaf also. We started one uh, research paper building using overleaf and doing the content creation on this overleaf, making a text file. Okay, I hope this makes a sense. And simple things, title, author, date, begin, make title, section, subsection, all these things. Points you can make, plots you can add, subsections you can create. You can bold anything as per your choice. These are the important terms used in the overleaf. Okay. Next, we will learn how to add a table. We'll try to see how we can add some maths. We'll see how to make an algorithm. Okay, how to add an algorithm, how to add the references. Practically, we'll see how to do all these. Then we'll finalize our paper in that way. Okay, got it. Yes, anything, madam, you want to say or ask, please. Anyone, any doubt, please let me know. Any questions, any queries you have, please let me know. Yes, any doubts or queries?
I think no doubt, sir.
So, ma'am, you understood, ma'am. I think everyone to get an idea or the knowledge about like practicals for overleaf latex preparation.
Yes, sir. Surely.
All right, madam. So this is what I need to talk for today's session. Thank you, madam. Okay,
Thank you, sir.
and it's very easy. Like what you have seen, I did in front of you. So like it could be thought some complex thoughts at how to make a overleaf template and like arranging all the things in overleaf and making all these latex files. It's been complicated. No, it's not at all. Once you start, you will get the suggestions, you will get the recommendations. Keep on experimenting from your side and try to reduce as much as plag or AI things, AI stuff, and keep on writing from your side. Okay, your paper will be built. All right, fine. Well, thank you. That's the day number.